Alright, so let's learn something a little bit new today. And today is the 29th. We're going to finish up section 9.5 today. And section 9.5, what we're going to be doing is solving rational inequalities. Okay. Now, when we're solving rational inequalities, it's going to be similar to how we solved radical inequalities. So let's take a look at an example. What if I asked you to solve, let's see here. A problem that looked like this. So it was x over 2 is less than x over 4. Okay. Now the first step we're going to be doing, so I'll write out our steps here. We have 3 examples today. First step is we're going to solve like an equation. Alright, so for step 1, x over 2 is equal to x over 4. If we multiply everything by the LCD, or we could cross multiply, the LCD would be 4 here. We'd get 2x is equal to x. So remember, we never divide by x's. We could lose an answer doing it that way. We always make it equal to 0. So let's bring the x over, and we just get x is equal to 0. It's easy enough. Second step is we used to set the radical equal to 0 in order to set it up for us to figure out extraneous solutions, which would make the radical negative. But for rational inequalities, we'd get an extraneous answer if the denominator was equal to 0. So for our second step, we make any denominator with x is equal to 0. So I'm going to put with x equal to 0. We don't have that in this case, so we'll skip that. We'll see it in the next 2 examples. Third step is we make a number line, and then we're going to test our regions. Okay, so for our number line, well, we only have one answer, that's 0. We didn't get anything from step 2. So I'm going to pick a number to the left of 0, like let's use -1. Pick a number to the right of 0, like let's use 1, and we're going to plug them in, and we'll see which ones work. If you plug in -1, you could use your calculator for this. The way that I would store it on your calculator is I would always get 0 on the other side. So on a calculator, I would set it up where instead of saying x over 2 is less than x over 4, I would make it so you get 0 on the other side. So x over 2 minus x over 4 is less than 0. So let's test our values into this and see what happens. I would only use this if we're storing on a calculator. It's just easier to do that way. If you're just going to plug them in regularly, it really doesn't matter which equation you use. So on my calculator, I'm going to type in mem variable. So I'm going to store -1, and then hit the store button for a. And then I'm going to type in in my calculator, I'm going to type in mem variable a divided by 2 minus mem variable a divided by 4, and see if that comes out to be less than 0. Mem variable a divided by 2 minus mem variable a divided by 4. I'm going to hit enter, and I'm getting -0.25 is less than 0, and that's true. I'm going to store 1 now. Go back to my equation I typed in, and I'm getting 0.25 is less than 0. That's not true. So if this is a number line, it looks like all numbers less than 0 are working. So all numbers less than 0, these numbers would be less than 0, these are greater than 0, would work. The last step we have to do is test our boundary numbers. So for step 4, x is less than 0, but what about could it be less than or equal to 0? So if I store 0 in, I'm going to test it out and see what happens. 0 store for a. My calculator is telling me that 0 is less than or equal to 0. Or I'm sorry. So we want to see, could x be 0, right? So if we plug 0 in, if it works, then we're going to put in or equal to, less than or equal to. So let's see what happens. If we put 0 in, we get 0 is less than 0, and that's not true. So because it's not true, it's not or equal to, it's just the regular that symbol. It's a little bit tricky here because we're using 0, but let's take a look at another example. I have a couple more examples that'll make things a little bit more clear. Remember, if you're testing the boundaries and it doesn't work, we use one of these symbols. If it is true, then we would use one of these symbols. That's what I should have said. So let's take a look at another example. So example 2, it says x minus 2 over x is less than x minus 4 over x minus 6. So we'll follow our steps. First step is we're going to solve it like an equation. So x minus 2 over x is equal to x minus 4 over x minus 6. Now, our least common denominator here would be x times x minus 6. We're going to multiply everything by that. Okay. Well, the x's cancel. And if we FOIL that out, that would be x squared minus 8x plus 12. And over here, the x minus 6 cancels. We get x squared minus 4x. Get everything on the same side. And I'm getting x is equal to 3. Okay, so that's one of the numbers we're going to have to use. Second step is we make our denominators with x equal to 0. So that means this one right here. X equals 0 is going to be another number. And that means this one right here. X minus 6. So x would be 6. So we have 3 numbers we're going to be using for step 3. Step 3 is we test on our number line. So we're going to be testing 0, 3, and 6. And the original equation was x minus 2 over x is less than x minus 4 over x minus 6. Now to store on our calculator, it might just be easier to bring this over. And see if we can get it to be less than 0. On our calculator, the way we would type this in is use parentheses to separate the numerator from the denominator. That would be how I type it into the calculator. Or you could just plug numbers in manually into the original equation if you want. Just plug them into the original. We just want to see if they're true for each of these regions. So we'll test numbers less than 0, between 0 and 3, between 3 and 6, and bigger than 6. So I'll test -1, I'll try 1, 4, and 7. And I'm going to type it into my calculator, so let's see here. So store -1, and I'm going to type in parentheses a minus 2 divided by a minus a minus 4 divided by a minus 6. Alright, let's see what happens. With negative 1 stored, my calculator's telling me we get 2.2 or 2.3 is less than 0. That's not true. If I store 1, hit 1 store, and I'm going to go back up to the equation I typed in, I get negative 1.6 is less than 0. So that's true. If I type in 4, I'm going to store it and go back. I'm getting 0.5 is less than 0. I don't think so. And if I type in 7, I get negative 2.3 is less than 0, which is true. So the last step we have to do is test the boundary numbers. So it looks like x is less than, x is between 0 and 3 works. We use this symbol, that means a union, to combine two different solution sets. So you could either use a union, or you could say or, whatever you want. They both mean the same thing, but in case you see that U, that means we're combining two separate areas. So I want to know, could x be 0? If it could be 0, I'm going to put or equal to here. Could it be 3? Or could it be 6? So let's store those and see what happens. If I store 0, I'm getting an error because we're dividing by 0, so I'm going to leave that symbol alone. The same thing's going to happen with 3. Let me see. Actually, no. If I store 3 and go back up, I get 0 is less than 0. Well, that's not true anyway, so I'm going to leave that symbol alone. If it was like negative 1 is less than 0, then I would make it like this. But because 3 doesn't give us a true answer, I leave that alone. And then with the 6, I get an error. So it looks like the best answer would be this. Okay. So I know there's a lot of steps. It's not really hard math, and I think you could all handle this. We'll do one more here. Hopefully by now it's getting a little bit more clear. We have 3 over y plus 2 plus 7 over 15 is greater than or equal to 23 over 3y plus 6. Okay, so for our first step, we're going to solve it like an equation. So we get 3 over y plus 2 plus 7 over 15 is equal to 23. I'm going to go ahead and factor out the bottom. And for our least common denominator here, we're going to definitely need a factor of y plus 2. It's going to take care of this and this. And between 15 and 3, the LCD would be 15. I'll multiply that out. Let's see what happens. Alright, so these cancel, giving us 3 times 15 is 45. These cancel, so 7 times y plus 14 is equal to, these are going to cancel. 15 divided by 3 is 5 times 23. So let's clean it up here. We get 7y plus 59 is equal to 23 times 5 is 115. So 7y would equal 56, and y would be 8. Alright, so that should be pretty easy. Second step is any denominator with an x, we're going to make equal to 0, or with a y, because this problem has y in it. So that's right here, y plus 2, So if we set those denominators equal to 0, we get y is equal to -2 for both. And to finish, I'm going to make our number line with -2 and 8. So we're going to be looking at numbers that are less than -2, numbers between -2 and 8, and numbers greater than 8. So we could use -3, we use 0 here, and we could use 9. So looking at the original, 3 over y plus 2 plus 7 over 15 is greater than or equal to 23 over 3y plus 6. In order to store this on my calculator, I'm just going to bring this over so it's 0 on the other side. So on my calculator, I'm going to type this in, 3 divided by a plus 2 in parentheses. Whenever you have more than one term in a numerator or denominator, we should use parentheses. And that's greater than or equal to 0. That's just going to make our storing easier to do. So let's see what happens here. I'm going to store -3. I'm going to type in 3 divided by mem variable a plus 2, and plus 7 over 15, minus 23 divided by parentheses 3a plus 6. And my calculator is telling me it's 5.1 is greater than or equal to 0. It's true. That's 0. Store 0. It's very quickly. Our calculator plugs it in. Get -1.9 is greater than or equal to 0. That's not true. And if we plug in 9, we get 0.04 is greater than 0. That's true. So our last step, let's just test our boundaries. So could y be less than -2? Or we could use a union symbol. Y is greater than 8. So what about -2? What happens if we use -2? And what about 8? So I'm going to store -2. And my calculator is telling me that there's an error. So it can't equal -2. That makes a denominator equal to 0. If I put 8 in, my calculator is telling me 0 would be greater than or equal to 0. That's what we typed in, right? And that's true. So I'm going to use an or equal to symbol here. This would be the answer. Doesn't matter if you use the union symbol or. All right, so for homework, what I would like you to do is on page 582, I would like you to please do numbers 20, 21, 24, and 31. All right, thank you very much. Have a nice day.